So I have another example here. We're using standard deviation. Brendan works in the canteen at his local community center. He's unloading delivery trucks, and he's curious about something. He has 227 gram bags of sunflower seeds, and he has 454 gram bags of sunflower seeds. And he wants to know if the company that makes these sunflower seeds is actually being truthful about the mass of the bags, or if they're trying to rip you off. Now, obviously, with any kind of food product or anything that's sold by weight, there will be a little bit of variation. Hopefully not too much, and hopefully the mean is close to, on average, what they say the package is. But what we can do with this is we can look at the mean and we can look at the standard deviation, and we can see, are these consistent? Are they accurate? We'll turn to the graphing calculator, enter the data, and again, as this is the third time through this, I'm going to go a little bit quicker than usual. Please pause the video if you need to catch up. So stat, edit, I'll enter the 227 gram bag masses. They're blended and weighed out. After getting in the right spot, my cursor was just off the screen, so it wasn't actually entering. Quit out of that. Go to the calculate side of stats, option 1. So for the 227 gram bags, we get a mean of 227.15, which is good. On average, these bags contain maybe just slightly more than they say they do, but that's okay for us as consumers. The standard deviation would be 5.2 grams. So there is a little bit of variation between the bags, but that would be expected. We'll do the same thing with the 454 gram bags. Stat, edit, go all the way up to clear out this data from before. Enter the 454 gram bags. Now, before I get finished and as I'm entering the data, we would assume that the mean would be around 454. But using the standard deviation that we got from the 227 gram bags, it would be a fair assumption to assume that the standard deviation would be double, since these bags are double the weight anyways, assuming they'd be the same amount of spread. It would also be reasonable to assume that the standard deviation would be similar, because if they're using the same machinery that is off by the same amount, it could be. One way to find out, now we have the data entered, we'll quit out, go to the calculate side, option 1. And for the 454 gram bags, mean is 454.4, so again, slightly above what it's stated, but not a whole lot. Standard deviation, though, is actually less, 4.5. So these 454 gram bags are actually more consistent in their mass than the 227s. Is that a good thing? Well, we do want consistency. We don't want to be the unlucky person who gets a bag and gets shortchanged, but also we do want to be the lucky person who buys a bag and gets a little bit extra. In reality, so that everybody's happy, it would be easiest to have a standard deviation as close to zero as possible. That way, nobody gets too much, nobody gets not enough.